Welcome back. Today we are going to do Unit 3 of Geography Class 7, that is our changing Earth. Now, what does changing Earth mean? Is the Earth really changing? Yes, over the millions of years, the land on the Earth has been shifting. You might have heard about the Gondwana land. Once it was a single big landmass, slowly it broke into parts, and India, which was earlier near the Africa and moved and later joined to Asia. But remember, it didn't happen in a single day. These movements take millions of years. Why does the Earth move like this? The reason is magma inside the Earth. Okay, the magma in the upper mantle and it moves in the circular motion. This is the surface, and this here the lithosphere ends, and this layer is the upper mantle. In here, the movement of the magma in circular motion. The magma in the upper mantle moves in the circular motion, as I told, like a boiling water. This movement creates a cracks in the earth crust, and that's how the land must slowly shift. Okay, in here, if this moves in circular motion, there is a cracks will occur in the earth crust, and this is how the land must slowly shift. Now, the force which act inside the earth are called as endogenic force, and our examples are earthquakes, volcanoes, and landslides. On the other hand, the force that works on the surface of the earth, like wind, water, or glaciers, are called as exogenic forces. Now, let's first learn about the earthquake. Okay, if, as I told, if this is the surface, and if here the lithosphere ends, as I told, this is the moment of the asthenosphere in circular motion. When this movement creates a cracks in the crust, if this creates a cracks in the crust, the pressure is released suddenly. That sudden release of energy makes the ground vibrate. That will vibrate. This is what we call an earthquake. The place inside the crust where the earthquake actually begins is called as focus. This is the area we call it as focus. And the point on the surface of the earth is directly above the focus. We call it the epicenter. The strongest damage always happens near the epicenter. As the waves move away, the effect becomes the weaker. So remember, focus means where the earthquake starts inside the crust, and epicenter means the point on the surface above the focus. Now let's come back to the volcano image and see how volcanoes are formed. Remember, I told you magma inside the magma moves in circular motion. When this movement becomes strong, cracks are created in the crust. Through these cracks, magma pushed upward, and when it reaches the surface, it erupts as a volcano. But here the question, why don't we see volcanoes everywhere? Why not beside my house, or why in your school side? Or the reason is volcanoes only form in special plate boundaries, not in everywhere. Now let's try to understand. At an oceanic continent plate, suppose this is the oceanic plate and this is the continental plate. This is continental plate. The oceanic plate is heavier and denser, so it goes down, as I told in the previous in class. If it while in the convergent, the heavier one goes inside, but the lighter one goes upside. In inside, what we have, that is the magma. When it reaches to magma, the magma will rises. Look at here, the magma will rises and it erupts. That's how volcanoes are formed. At the oceanic convergent boundary, also the same thing happens. One oceanic plate goes under the other and melts, and magma comes up to form volcanic islands. But in continental convergent boundary, volcanoes are not formed. Why? Because both plates are light and neither one easily sinks. Instead, they crash and push upward, forming the fold mountains like the Himalayas. Since no plate is sinking into the magma, so no new magma is generated, and that's why no volcanoes will appear. So remember, volcanoes do not form everywhere. They are mostly found where plates meet, especially at the subduction zone, that is in oceanic continental or oceanic boundaries. And look at here what I told about the earthquake. The lithosphere plates moves, the surface of the earth vibrates. The vibration can travel around the earth. These vibrations are called earthquakes. The place in the crust where the movement starts is called focus. This is focus. Okay, and the place on the surface above the focus is called as epicenter. Okay, when the energy released in this area, this will reaches to next one. For example, imagine the magma inside the earth is moving in a circular pattern. Now, when the crack or damage occurred at the one point, suppose this point is called as focus. The energy doesn't stay there. It travels to the connected rocks. If these are the connected rocks, and since all the rocks are linked, the energy moves from one to another until it reaches the surface. The point on the surface directly above the focus is called the epicenter. When the energy reaches the surface, it spread out in all directions, causing the shaking we feel during an earthquake. That's why an earthquake can affect areas far from the focus, but the strongest impact is always near the epicenter. Now, let's learn about the major landforms. First, what is a landscape? A landscape is shaped and worn down by two main processes, that is weathering and erosion. Here, weathering is the breaking up of rocks on the Earth's surface. Think of it like nature slowly cracking rocks into smaller pieces over time. Erosion is the wearing away of the landscape by agents like water, wind, and ice. Erosion actually moves the pieces created by weathering to other places. Now, let's see the work of river in the shaping land. Rivers are amazing. They twist and turn across the plains, forming large bends called meanders. Look at this structure. This is what we call as meanders. Over a time, the loop of the river may get cut off and forming a cut-off lake, also called as oxbow lake. And isn't it interesting how rivers create their own little lakes? During floods, rivers deposited layers of fine soil and other materials along their banks. These deposited layers form a floodplain, and raised banks on either side of the river we call as levees. These ones. Okay. Now, when a river approaches the sea or the ocean, it often splits into several smaller channels. These called as distributaries. And together, these distributaries form a delta. And formally, you can think of it like this. There is the river starts in the mountain, right? It forms in mountain. As it flows down, it carries clay, silt, and other sediments. When it reaches flatter land or the sea, it deposits these materials, creating features like floodplains, levees, oxbow lakes, and deltas. So rivers are like nature's sculptures. They shape, deposit, and transform the land over thousands of years. Every bend, every plain, every delta tells the story of moving water and changing earth. Now let's see the work of coastal, glacial, and wind process in forming landforms. First, coastal process, how the sea shapes the land. Look at this diagram carefully, and here we see the sea caves. And how does it form? Well, every time the waves hit the rock becomes weaker and weaker, eventually forming a cave. Other features forming by the sea include stacks and isolated columns of rock left standing after the surrounding rock has eroded. Next one is sea cliffs, and that is steep cliffs formed as the wave erode the coastline. It's important to remember these names. They are the key coastal landforms. Okay. Now let's see the work of ice or glaciers. And glaciers are the slow-moving rivers of the ice that erode and deposit materials. One important feature is glacial moraines. And moraine is made up of material carried and deposited by glaciers, big rocks, that is small snows, stands, and clay. And glaciers act like a giant bulldozers and eroding the landscape and exposing solid rocks below. Finally, the work of wind, especially in desert. Wind erodes the lower part of the rocks more than the upper part, forming the mushroom-shaped rocks. And also when the wind stops, sand falls and gets deposited in small hills called sand dunes. And when sand is deposited over a large area, it is called as loess. Okay, so remember, sea forms caves, stacks, and cliffs, and ice forms moraines and scores of rocks, and wind forms the dunes, loess, and mushroom rocks. Okay, don't worry if you don't remember everything now. Just focus on how volcanoes are formed and the key landforms process I talked about. They were very important for exams. So that's it for this unit. I will upload the next chapter soon. If you found this lecture useful, like, share, and subscribe. See you in the next class.